Hey guys, today I'm going to talk something about the recursion algorithm. I know there are lots of guys on websites often like to use the examples, specific examples like a Tower of Hanoi or Fibonacci sequence to explain it, but I'm going to use my way to express it, how I've learned it, how I've mastered it. The first thing is definition. Before doing everything, we must know what it is. So the definition, you need to read. If you don't understand the recursion after you learning it, I hope you guys can go back to check the definition over and over again. Because when you read it, you can generate different ideas, different thoughts to it to help you. The definition of recursion. So the definition of the recursion is like the function calls itself repetitively. The function calls itself repetitively. It means we just assign a task. We don't need to manually code the function by ourselves. If the program really needs us to code a lot of things just by using the same function, we don't want to do the same thing, just like the function calls itself for us. But here is another important thing. Lots of people, when new beginners, they usually ignore is that the function must contain the right base cases. That's why we need the base cases in recursion algorithms, because the base cases are given values. We must base on it and to calculate to get the answers that we need. So base cases, you have to list all base cases in your recursion function. You have to list all base cases, not only one base case. You have to list all base cases. Okay, let me just go into explain it. And how does it work? How does recursion work? And okay, sorry, maybe before it, let me talk about why we need recursion algorithm. So it's my understanding. The first thing I think the recursion algorithm is very just to reduce the workload for programmers. Why I want to say like in this way? Because the recursion is like a function calls itself, and if in the program in the application we need to achieve the same function for several times, for many of the times, it's going to be boring for our programmers or coders. Maybe it's going to be a disaster, just coding the same thing repetitively and you don't see the destination. So you must be upset about it. And the occurrence of the recursion, it means, okay, just let the function let it call itself, and until we get what we want. So it's really reduced the workload for programmers, for coders. And another one is that it's a clean way to code. It's really a clean way to code. As I mentioned, in the block of the codes for recursion, it usually just contains several base cases, and you just use else to write something. Okay, if you haven't reached the base cases, you have to do something. You have to let your function call itself again. So it's the basic structure, it's the fundamental structure for the recursion. It's very simple. The structures are very simple. So it's a clean way. It's a clean way. Sorry, it's a clean way. It's a clean way to code. And okay, let's move to next section. I want to talk about it is how does it work. It's very important here. Lots of people they although they are doing lots of problems, they are solving lots of problems for recursion, but they don't get the core idea of the recursion. So I just want to explain it here and let you guys have a clear view of it. The first thing is that we want to get it. We have a function. Suppose we have a function, and maybe we don't have the return type. Just like a function is called just called a recurse. Just call it recurse. Recurse func. Yeah, the function's name is recurse func, and we are passing the parameters and just about parameters. Passing parameters here. It's going to be the basic structure for a recursion. So here we have some codes for the some codes for base cases. For example, let me explain. If just like if we use if here, we're going to use if here. If n equals to 0, it's a scenario. It's the situation here, and to consider about it, if n equals to 1, maybe n equals to 0 and n equals to 1 are base cases, or just the n equals to 0 is the base case. We don't care how many base cases we have, but we need to list them all. You have to list all of them. Okay, why? Because you need to check the. Let me just do analysis. Let me just do analysis. Analyze the execution order of recursion. So this function, this is the entry. We pass in the parameters here and to execute the function called recurse func. And we got the parameters. We pass in parameters here, and let's do it. Let's call the function. And the first step, we need to check the base. Also, you can call it the stop case. Base case, aka also known as the stop case. So the stop case, that means they are given value. They're with given values. So when we reach the base case, when we reach the stop case, okay, the programming can be stopped because we got what we want. And so in this case, I just want to use n equals to 0 and n equals to 1 as the base cases. Just an example. For the particular problem, you need to define your base cases by yourself. Okay. And after it, we're gonna do it. Else we're gonna do something else, right? We're gonna have the function like the function gonna call itself recurse func. Maybe we're building the next step here. Sorry, we're trying to building the connections between the items. Yeah, recursive func, we are passing the parameter here just like maybe equals to n, and we're going to hold it. So the connections and the relations, I just try to just use it as an example. So recurse func, maybe I just have the n minus 1, n minus 1 and multiply the recurse func and the n minus 1 and plus randomly. I just randomly type the codes. It's not the rule. You don't need to follow this pattern, definitely. It's just an example to show you how does it work. and this is the core idea. Sorry, this is the core idea of recursion, and maybe plus the recurse func, and here going to be a n-2, yeah, of the downlit, and this is the core idea of recursion. So let's just look at this. We got the parameter n, and this function is like we're trying to build the connections between the different items, just the previous items. Here is a recurse func, but the parameters passing here is n-1, right? And it's the same function, and the passing parameter is n-2. We just build a connection with between the recurse func n and the recurse func n-1 and recurse func n-2. So when we meet here, the whole workflow of the function is that we're passing the parameters here. We start the function, we check the base cases. Okay, we haven't reached the base cases. We don't have the given value. We know nothing here. And we're going to do is, so it's come to the else. We're going to do recurse func n, the parameters, the final results we want to know, and equals to the recurse func n-1 multiply n-1 and plus the recurse func n-2. Here the recurse func, we don't know here, we don't know n, we don't know the result of the recurse func n. We don't know the recurse func n-1 either. We don't know the recurse func n-2. But from here we build the connections. Here we meet this one, we don't know. We're passing the n comes to here again to the function itself again. The parameters became n and and the n-1. Sorry, it's the n-1. We met with it with n-1 passing back to the parameter here, and it executes the code again to check it. So the n-1 doesn't equal to 0. And it doesn't equal to 1, and it call it again. So here is going to be the function like, okay, here the pattern like recurse func. Here because we passing n-1 here, and the n-1 come here is n-1, and equals to m-1 minus 1, and multiply recurse func n m-1 minus 1 and plus recurse func m-2 minus 1, right? So what does it mean? It became recurse func m-1 equals to m-2 multiply recurse func m-2 and plus recurse func m-3. So you can check here. You can check this one and this one. Hold on. Let me just tell them. I just change the color to red. Change the color to green. To blue. Yeah. So here you can see that the recurse func n is the final answer we need. We need to return the value recurse func n, but we don't know it, and we're passing the n. We're just trying to build the connections, and passing the m-1 here, and in order to calculate the recurse func n, we have to calculate the recurse func m-1 firstly to before it, and I guess you guys already know that recurse if I want to calculate the result of recursive func n-1, we need to calculate the recursive func n-2, and yeah, from here and until n-2, right? Here is n-3, and n-3 passed here to calculate everything, just like you need to pass in the parameters to the function again. It's the entry of the function to do it over and over again until we reach the base cases. So we're gonna meet the if n equals to 1 and if n equals to 0, and we build the connections. Yeah, we can calculate. We got the answer. Maybe we got the answer. The recursive func, because we already know that the base case is that recursive func 0. Maybe we know the value is equals to. Maybe we know that it equals to the. Maybe it equals to the 0. Yeah, and the recursive func 1 maybe equals to the. Maybe equals to 1. Yep. And here, until here, we just calculate the recursive func n, and wait. In order to get the value of recursive func n, we need to calculate recursive func n-1 before, and have to calculate the recursive func n-2 before calculating the recursive func n-1 until we reach the recursive func 2. Yeah, until we reach here, we're going to build a connection like n-1 is n-1, and we just equals to n-1. It's n-1 is like 1, and multiply recursive func 1 and plus the recursive func 2 or recursive func 0, sorry. So here this value is given is 1, this value is given is 0, so we just get the answer. Sorry for the example, because maybe the values are just assigned here is not rational, is not proper. But yeah, because the recursive func 1 we already knew it, and the recursive func 0 we've already known it, so we can calculate the recursive func 2, and after knowing the result of recursive func 2, and we can get the answer of recursive func 3, and after getting it, we can calculate it and get a recursive func 4, and until we back from the end, from the given value, we just back to return the value to the function that call it. The recursive func 2 calls the function recursive func 1 and recursive func 0, and until we just get this one is our target, is the target value. We need to calculate the recursive func n. So when we just get the answer of the recursive func n-1 and the recursive func n-2, we can get the final answer of the recursive func n. So it's the whole. This means the whole workflow. It means the whole workflow of recursion. So it's like we just call the function calls itself, and we still kind of figure out the answer and call the function itself again until just from the top layer and call the function until reach the bottom. You got the answer, and the answer from the bottom is going to be returned to the it's going to be returned to the top step by step. So I think it's the workflow of recursion. It's my understanding. And what I'm going to say, yeah, the understanding is that you want to calculate everything. Don't forget the base cases, because the entry of this function, the first step is going to check whether the function has arrived at the base cases, have reached the basic cases. If not, we just continue to do the function, let the function call itself. It's the target. So the base cases are the given value we already know. And we have to do the function and let function call itself until we reach the base cases. So here is the parameters. So that's why I think you already, after my explanation, you should have a clear view of how the recursion work. The parameters just means you got a different parameters here, like n parameter, n-2 parameter, and n-3 parameters. So they're just the different parameters passing here, but they are doing the same thing. They are doing the function called recurse func. They're doing the same thing just by passing the different values, different parameters into the function. So you're trying to see that, check the base cases, okay, and then haven't they reached the base cases, okay, I call it again, and go to the entry again to check the base cases again, not reach the basic cases, okay, call it again. It's loop again, and until you get the given answer, and from the given answer, from the bottom, you return the value to the top, you got the final answer. Okay, cool. I think, yeah, it's my understanding. I hope you guys like my sharing.